Alright, so this is going to be a video that's a continuation from the last one about area of a plane region. So in the last video, if you haven't watched it, you're going to need to watch it, but the last video, we broke up this interval into two different equally spaced intervals, okay? So the width of the rectangles that we drew were both 1. Okay, so that's our n equals 2 because we drew two rectangles for the upper and lower bound underneath this curve. For this video, we're going to try to see if we have a trend, or if we can find a trend if we increase that interval, the number of intervals I should say, to 4 instead of 2. So the first thing we're going to do is break up this interval into 4, and then we're going to draw our rectangles and then try to calculate the area. So here we go. Alright, so we have 4 separate intervals, and we have 2 spaces from 0 to 2, so that means that the intervals should be broken up into halves. So we have 1 here, 1 here, 1 here, and 1 here for our rectangle. So each one's going to be a half because we have 4, and 2 divided by 4 is going to be a half for each of these. So I'm going to draw upper bound rectangles at each of these points. Okay, and we're going to use the curve right here so we can find our height. So we have a height right there. Now we have our 4 rectangles. We're going to try to figure out the area of all of these and then add them up. So here we go. So we have the area is equal to the length of the first one times the width of the first one plus the length and width of the second one, third one, and fourth one. Okay, so the first length in this case is going to be up to the curve right here. So this value right here is just going to be f of 1/2. So I'm going to write a is equal to, for the length, it's going to be f of 1/2 times the w. In this case, the w is going to be a half because it's from here to here. W is 1/2. So I'm going to write f of 1/2 times 1/2 plus length 2 goes from here to this point on the function, so at 1, so I'm going to write f of 1 times the same width of 1/2, because our widths are 1/2 for all of these. Then the next one, this third rectangle right here, it goes up to f of 1.5, so whatever f of 1.5 is for this function, that's our height. So I'm going to write f of 3/2 times 1/2 plus our fourth length right here, it's all the way up here, it's going to be our f of 2 times 1/2, because again the width is 1/2 here, 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 and here. Okay, let's simplify this. F of 1/2, if you plug 1/2 in there, you'll get 1/4, because it's 1/2 squared times 1/2 plus f of 1 is going to be 1 times 1/2 plus f of 3/2, now you're going to get 9/4 times 1/2 plus f of 2, which is 4 times 1/2. Okay, just to simplify this really quick, you should get, if you add all these up, you should get 3.75. Okay, so that is with the upper bound rectangles of 4. If you notice before, when we had 2 rectangles for it, we had 5, now we have 3.75. Alright, now let's do the lower bound. Alright, so for the lower bound, this first one, we're not going to be able to go anywhere with it too, because we can't be underneath the curve right here because it's 0. So I'm just going to put another line here. The next one, it's going to be, again, this first one technically isn't counted as a rectangle because it's really just a line, but just think of it as a rectangle with an area of 0 if you want. Okay, so now what we're going to do is we're going to find the total area of these 4 rectangles. Okay, now this is going to be equal to, well, the length right here is 0 times the width of 1/2. So that's just going to cancel out to 0. The next one, we have the f of 1/2 as the height, so I'm going to write f of 1/2 again, times the width of 1/2 plus the length of this next one is going to be the f of 1, so I'm going to write f of 1 in here, times 1/2 plus the length of this last one, it goes from, it's the f of 1.5 or f of 3/2 times 1/2. Okay, let's simplify this. So we have 1/8 plus 1/2 plus 9/8. So if you add these all up together, you should get 1.75 for your final area. Now if you see right here, it's 1.75. The first time we had n equals 2, we ended up getting 1. So as you can see, the area is still in between these two values. When it's in between these two values, we're just getting closer and closer to it. So we're finding that middle ground of what the area actually is the more we increase the number of intervals we use. So hopefully this kind of helps you understand the trend here. The more rectangles we have, the closer and closer and closer we are going to get to finding the actual area under the curve. Now, what does that mean in calculus terms? Well, now think, what happens if n goes to infinity? Okay, so if n goes to infinity, how does that work with the area underneath this curve? We're going to wait for that for the next video.